Howdy and good day, fellers. Today in Algebra, we'll be learning a new form of a linear equation because, well, quite frankly, the world just doesn't have enough of them. We've already learned about standard form in Unit 3. Standard form looks like this: ax plus by equals c. And kind of the thing about standard form is that, remember, a, b, and c cannot be fractions, right? They have to all be integers. We talked about slope-intercept form before, and that looks like y equals mx plus b. And that's a real handy equation to graph a linear equation really quickly when you know the y-intercept and the slope. Okay, so a third way to write a linear equation is called point-slope form. Point-slope form. And this one is really handy when you have the slopes. That's kind of a requirement for both slope-intercept form and point-slope form, and just another general ordered pair somewhere on the line. Does not have to be the y-intercept. So whereas in slope-intercept form, you need the slope, that's the m, and you need a specific point, right, that y-intercept point. In point-slope form, it can just be any other point, okay, not the y-intercept. So both of these can come in handy kind of based on the information that you're given. Both of them can help you write the equation of a graph, particularly when your y-intercept is like a fraction, you know, like if it crosses at 3.5, sometimes it's going to be kind of hard to tell on the corner plane. Well, is that 3.5 or is it 3.6, right? So point-slope form can come in handy for writing linear equations, but also graphing them if you don't have the y-intercept. And it looks like this. Point-slope form is y minus y1. Now we've seen that y1 before in our slope formula. Remember, that just means like it's a first y. Okay? It's not y to the first power, y times 1. It's just like it's an order thing, the first y. Equals m times x minus x1. Okay? Y minus y1 equals m times x minus x1. And we're going to kind of take this in pieces here, okay? Because it can get a little bit confusing with the x and the y and the x1 and the y1, right? So let's start with, and I'll underline them in blue and write them in blue, the y and the x here, okay? The y and the x, the y value of any ordered pair on the line. And this is the one that when you write the equation, it's going to remain the variable y, right? Like in slope-intercept form, we had y and we had x here, and we used those to maybe calculate the y-intercept, but when we wrote the equation, it stayed y and it stayed x. That's the same thing here. This y that I've underlined in blue here is going to be y when you write the equation because it represents any y value of any ordered pair that makes the equation true. And the x is very similar. It's going to be the x value of any ordered pair on the line. And just like the y, that x is going to remain an x when you write an equation in point-slope form. Right? Every linear equation has to have an x and a y variable in it for the x and the y-axis. Okay? That y and that x, I've underlined in blue there, those are the ones that are going to stay y and x when you write the equation. The y1 and the x1, which we'll underline in red here, are values that you're going to replace with numbers because they represent a specific point on that line. It can be any point that you choose, but it's specifically calling out a point. Okay? So the y1 is the y value of a specific point on the line. And the x1 is the x value of a specific point on the line. So when you write the equation, they will be replaced with numbers of an ordered pair that you choose. And the easy one, because we've worked with it before, that m variable, that is once again the slope. Okay? And what does this form tell us about the graph of the line? Well, it gives us two things. It gives us the slope, and it gives us an ordered pair on the line. It gives us the slope, and it gives us an ordered pair on the line. And again, how this differs from slope-intercept form is that in slope-intercept form, you're given the y-intercept. Okay? In point-slope form, it's another point. It's a different point, not the y-intercept. Right? So, let's take a look at some examples here. Okay? It says, write the equation of the line described in point-slope form. For the bottom three, show how you calculate the slope. So these top three, which you will have at least one of these, this type on your test where I give you the slope and I give you a specific point. That's what you're looking for, right? The slope of the line is 7 and it passes through 6, 4. Now, if you think back to last unit, when I asked you to write this in slope-intercept form, you had to use that ordered pair, plug it into the equation to solve for b to specifically get that y-intercept. In point-slope form, you don't have to worry about that, okay? Because 6, 4 is the given point that we're going to use. It's a point on the line, and we're going to use it to write the equation. So the general form of the equation is y minus y1 equals m times x minus x1, okay? Remember that first y and that first x, and I shouldn't say first and first because we have the 1 and the 1, but the y and x we underline in blue up above, they are going to remain y and x when we write our final equation. All right, so those don't change. Okay, what we plug in are the values for y1 and x1, which come from the given ordered pair, that 6, 4. Okay, this would be our x1 variable, and that would be our y1 variable. So when we write the equation, y minus 4, the value for y, equals our slope of 7, so that's a given as well, times x minus 6, because that's that x1 value. Okay, so y minus 4 equals 7 times x minus 6. And we're done. This is the equation in point-slope form. Okay, let's look at the second one. The slope of 1/3 passes through -2, 1. So again, here's our slope given to us. Here's the specific ordered pair that this line passes through. That represents our x1 and y1 values. And so in our equation, which I'll write the general form up above here, y minus y1 equals m times x minus x1. Y and x don't change. We get to plug in the slope, which is 1/3, and the x1 and y1 values. Now, since that x1 value is negative, remember when we had slope and that slope formula, and it was like y2 minus y1 over x2 minus x1? When we had a negative ordered pair value, since we needed the subtraction sign in the formula and the negative sign of the value, it changed to addition. The same thing happens here. Rather than writing x minus -2, because both of those signs need to be included, the subtraction sign in the formula and the negative sign of our x1 value, we're going to write x plus 2. Okay, x plus 2. And then y minus y1 is going to become y minus 1, the y1 value of the given ordered pair. So y minus 1 equals 1/3 times x plus 2. And the reason why it's a plus 2 is because this value is negative. Okay. Slope of -5 passes through -8, -4. So here's our slope. Here's our x1 value. There's our y1 value there. In the equation, the y and the x remain y and x. We can plug in the slope, -5. And then this first y value, or this y1 value here, since it's negative in the ordered pair, instead of writing y minus -4, we're just going to write y plus 4. Okay? Whenever you have that negative value in the ordered pair, in the formula, it's going to be plus, because the subtraction sign and that negative sign cancel out. The same thing happens with our x here. Instead of x minus -8, it's going to be x plus 8. So it's almost kind of backwards. It's almost kind of opposite when you think about it. When the value is negative in the ordered pair, it becomes positive in the equation. And when it's positive in the ordered pair, like we saw here in 6-4, this 4 is positive. It's a -4 here. This 6 is positive. It's a -6 here. It's kind of in terms of opposites. And that's going to be something to keep in mind when we graph it tomorrow. Okay, tomorrow we'll be graphing in point slope form, which will also be a live lesson tomorrow. So when it comes time for class, make sure you log into Google Classroom, get the Zoom link, and then join us for graphing in point slope form live with Mr. Schultz. It's going to be great. Okay. The next three, all I give you are two ordered pairs here. Okay, passes through 3, 6, and 9, 4. And remember, what we need for point slope form, we need the slope, and we need a specific point. Well, I give you 2 points you can use. You can use either one for your final answer, but I don't give you the slope. So here's where we go to our slope formula, and we have to do some calculation first. Subtract the y values, subtract the x values, and we get -2 over 6, which we can reduce to be -1/3. Okay. If you need to look back on how to use slope formula, you can take a look at CO29 for help there. Okay. Now that we have the slope, we can go ahead and we can write our equations in point slope form, and we can use either ordered pair here because both of them are ordered pairs that are on the line. So using 3, 6, our answer would be y minus y1, which would be -6, equals the slope, -1/3, times x minus x1, which would be -3. That's one option. If we use the second ordered pair, if we use 9, 4, well, now it would be y minus 4, because 4 is the y value, equals -1/3 times x minus 9, because now 9 is the x value. So you can use either ordered pair, okay, because both of them are on the line. They're both valid in that respect. But you need to find the slope first. So looking at the second one, passes through -1, 8, and -3, -10. Our first step here is to find the slope. So we have the difference of our y values, -10 minus 8, over -3 minus -1. So here we see, right, we're subtracting a negative, same just like in the formula, just like in point slope formula, it actually ends up being -3 plus 1. So we get -18, -3 plus 1 is -2. Our slope ends up being +9. If we use the first ordered pair, -1, 8, our answer would be y minus 8 equals slope of 9 times x, but instead of minus -1, it becomes a +1. I mean, we see that opposite relationship there. That x value is negative in the ordered pair, it's going to be positive in the equation. That 8 was positive in the ordered pair, it's negative in the equation. And the reason why is because point slope form has those subtraction signs as part of the formula. Okay, part of the formula. If we use the second ordered pair, -3, -10, this time it would be y plus 10 equals our slope of 9 times x plus 3. Right? And the last one's here. Slope. Subtract the y is 7 minus negative 3, which ends up being 7 plus 3, and negative 1 minus 5. So we have 10 over negative 6, which simplifies to be negative 5/3. Negative 5/3. Using the ordered pairs, one option, y plus 3 equals negative 5/3 times x minus 5. The other option, y minus 7, this is using this second ordered pair here now, y minus 7 equals negative 5/3 x plus 1. On the test, you would need to write them both. Okay, you would only need to write one of those because both are acceptable equations of that line and point slope form because both have the slope and each contains one ordered pair that's on the line. Then the bottom section there, rewrite the following equations in slope-intercept form. So we're going from point slope form to slope-intercept form, which basically means, remember what slope-intercept form is? We want to get the y variable by itself. Y equals mx plus b. We want to get the y variable by itself. And get rid of those parentheses on that right side, because there aren't any parentheses in slope-intercept form. So this first one here, and this is going to be the same kind of process for all of them. So if you can do it in the first one, you'll be able to do it in the other three. Get rid of those parentheses by distributing the coefficient, the slope, essentially, into the parentheses. That gives us y minus 7 equals 2x plus 6. Then, to get y by itself, add 7 to both sides, and we get y equals 2x plus 13. Y equals mx plus b. We're done, right? Notice the slope doesn't change. The slope was the same in point slope form, 2, as it was in slope-intercept form, but this gives us different information. Point slope form tells us that this equation, or this line is going to pass through the point negative 3, positive 7. Remember that those opposites there, right? Negative 3, positive 7. This one tells us that the y-intercept is going to be at 0, 13. Okay, so different information written a different way, and the ability to change and manipulate from one form to the other, it's a valid skill because it tells you something different. Okay, you can do the rest of these three on your own. At least one of them will show up on your Google quiz, which is over on Google, obviously. You can get there from Google Classroom. It is due tomorrow and live lesson tomorrow. I'm so excited. Look for the Zoom link at class time, and we are going to be graphing equations in both point slope and the slope-intercept form. But until then, have a great day. If you have questions, see me during office hours from 1:30 to 3. The Zoom link for that is also posted in Google Classroom. Don't forget to like and subscribe. Have a wonderful Tuesday.